principle we're going to talk about is systematic problem solving. Now, like the rest, we're going to start with thinking about this from the behavioral standpoint. There's plenty of tools and methods that we can attach to this principle, but what about the behaviors? Well, the first is actually just deciding to do it. If you take any course on problem solving, it often begins with shaping a problem statement. But what happens before that? You have a litany of things going on in your organization, your inbox is full, you have meetings all over your schedule. What triggers you to actually initiate doing problem solving? That's a behavior in most cases, a choice that you have to make. And that really is the beginning. Now, along the way, as you get into problem solving, I think one of the most important behaviors is the curiosity to learn. Because we actually have a knowledge gap. We have a learning opportunity. If we already knew what we needed to know, then it's not really problem solving. We should just execute what we know. But most problem solving is inherently a learning exercise. We have things to learn about why that problem exists. And so we need that behavior of curiosity to make it powerful. It also, most of the time, requires collaboration. Very, very infrequently does one person doing problem solving produce the right result. And so whether it's vertically or horizontally across your organization, collaboration becomes a key behavior to make problem solving successful. Also, executional discipline. So often problems get started and dropped and we move on to other things and get distracted without really seeing the thing the whole way through. And so we need that executional discipline. And lastly, test. Not really a behavior, but the behavior that really I mean to capture is questioning our assumptions. But what that shows up as is test. Test everything. Test your problem statement, test your potential solutions, test that when you implemented it, it really produced the result that you wanted. And this is particularly important as you get to the end and you're really ready, confident in your answers, ready to declare victory. It's really time to test that point and challenge whether you really got the answer or you didn't. Get these behaviors right, and however many skills you pick up around problem solving, you'll ultimately be more successful. So let's talk about the word systematic in systematic problem solving. Now, there's lots of structures, whether it's 8D or 7-step or A3s, or there's all sorts of different methodologies that really provide that systematic approach to problem solving. Now, I'm not going to spend a lot of time trying to convince you of one over the other, but the point is, why is this systematic approach important? After all, we've all been solving problems since we were babies. It's a fundamental human condition. But it doesn't mean we were good at solving problems. It certainly doesn't mean that we're good at solving complex or difficult problems. And so that systematic approach actually is meant to force us out of some of our bad habits. For example, our habit might be to jump to conclusions. It's pretty common behavior among most people. And certainly when you get into problem solving, we jump to solutions, we jump to conclusions quite quickly. Well, most structures in systematic problem solving force us to slow down, to go through those steps in a more deliberate manner. Now, this doesn't make it a recipe for success. It doesn't mean it's a linear thing that should be followed A through Z, but it provides a systematic approach that forces us out of some of our bad habits and pushes us towards better habits for effective problem solving. Now, we're not going to get into problem solving methodology here, but it's important to understand that there's not one tool that fits all situations. So the best way to describe problem solving is at 4 different levels. First is basically troubleshooting of known solutions for known problems. Now, if you're driving along and the gas gauge on your car says E, you don't need to pull out problem solving tools. You put fuel in the gas tank and you're on your way. You know what the solution is. So don't spend any time documenting what needs to be done. You just execute what you know. The next level is when you really think you know the answer. Well, that's a time to test. Right? It's much more efficient to test whether the solution actually works or the idea works than spend a lot of time building up to something that you're going to test anyway. If you find out that that solution doesn't work, you can always move on to the next stage. But if you think you know, test. Now, the next, which is probably the most common when we really think about systematic problem solving, is when we really don't know the answer. This is when we have to understand cause and effect. It's when we probably have multiple different solutions that could contribute to solving that problem or closing that gap. And so these types of problems are really about knowledge, and this is where most of your systematic problem-solving methodologies start to come into play. And the highest level is when the problem is not just highly complex, but highly cross-functional. It's going to require a tremendous amount of collaboration, and often some sort of facilitation is needed to get multiple parties coming together to work through the problem in a collaborative fashion. Now, why I share these levels is it's important to not do any more problem solving than is necessary. The reason this is important is there's an endless array of problems. We'll never actually get to them all. And we need to apply the right level of resources to the right problems in a way that doesn't contribute to the waste. And that means we don't do A3 problem solving on putting fuel in your car. That would be a tremendous waste of resources because we know what the answer is. All right, so we don't want to do any more problem solving methodology or effort than is necessary, but in most cases, as many real problems are knowledge gaps, it still requires a deep investment of time, energy, curiosity to really close the knowledge gaps that allow us to move forward. While we can't talk about all the problem-solving methodologies, I thought it was worth taking a little time to talk about the 5 whys. Why? Because it's a great chance to demonstrate some of the key aspects and behaviors, mindsets that go along with problem solving. So we take a problem statement and we ask why that problem occurred. That's the first why. We get an answer to that question, the first immediate connection to that answer, and then we ask why that occurred. Once we get an answer to that, we ask why that occurred, we ask why that occurred, we ask why that occurred, until we get to a root cause. Now, an important aspect of this is that these have to be clear linkages between one and the next. The best way to know this is reverse test, meaning that once you get an answer, ask, if I eliminate that, does the previous why go away? If it doesn't, then you might have a contributing why, but you don't have the real why. Now, the whole point of this is to dig to get to a root cause, at least a root enough cause, that you can solve. I actually think it's bad that we've called this the 5 whys because the number 5 is really an error. There's nothing magic about the number of whys that you ask. Sometimes it's 3, sometimes it's 9. So when I see an organization that has a template with 5 whys on it, I know they're really not using it in the right way because they're stuck on the number 5 instead of getting to a cause that they can solve for. Now, if you really want to try, you can keep digging and keep digging. I'm reminded of an old tale. I have a small statue of turtles stacked on one of each other. And this is an old mythology around what holds up the earth. And the story goes, well, what holds up the earth? Well, it's a giant turtle. And what holds up that giant turtle? Well, an even larger turtle. And then you get to the point where it's just turtles all the way down. The point is you can keep digging and keep digging to the point where you get to world peace and world hunger and issues that you can't do anything about. The key is to get to something that you can solve for. An activity, connection, and flow, a breakdown in mechanics, something that you can change that will resolve that problem. And so the whole point of this is to test cause and effect. This is a common theme, is to suspend our assumptions, to study with curiosity, and to test cause and effect. And these strings of whys are an opportunity to do that without worrying about a bunch of templates and methodologies, to continue to test what caused this problem and dig deeper and deeper until we truly understand it. In the end, whatever tools and methods that you choose, this is what systematic problem solving is all about.